Okay, we're going to work out the Laplace transform of the constant function 1. And this means f of t is equal to 1 for all t. And we'll be using the definition in this case. So let's see. The Laplace of 1 is going to be the integral from 0 to infinity. And we always have e to the negative st. And we multiply this by whatever this function is, which is just a 1 right here. And this is not bad at all, right? And remember, we have to integrate this with respect to t. So let's put down dt right here. And now, as you can see, this is an improper integral, so be sure you write it down legitimately. We take the limit as n goes to infinity. And of course, you can use other letters right here, up to you, but in this book, we'll use capital N. Anyways, right here, we will have the integral from 0 to capital N, and this is just e to the negative st dt, all right? And now we just have to do our integral and then believe in our limit, right? So let me once again write this down. The limit as capital N goes to infinity. Let's integrate this. Well, we have to integrate with respect to t. That means s is a constant. E to the negative st, we will first have e to the negative st. And we look at this and we differentiate this. The derivative of negative st with respect to t is negative s. When we do integral, we divide by that, which is dividing by negative s, which is the same as 1 over negative s right here, right? And we have to integrate this from 0 to n. And now, plugging n into t, plugging 0 into t, and then we subtract two things. So we will have the limit as n goes to infinity. Plugging into here, we will have 1 over negative s e to the negative s times n. And then this is the first part. We will subtract. Plugging 0 into here, we will have 1 over negative s e to the negative s times t, which is this 0. And that's what we have right here. Okay, so depending on how you want to do it, and you see that this is actually the troublesome because we have n goes to infinity right here with this n. This is just going to be nice because you have 0, so you know this is going to be nice. But let's talk about this. Well, when you have e to the something, either you get infinity or 0, right? When you have power being infinity like that. Imagine if the whole thing right here becomes infinity. That would be bad, isn't it? Because infinity minus whatever right here. This is not going to be infinity. The whole thing will be infinity. That's not good. So we want this part. We want this part to be equal to 0. And how can we have that? Well, n is going toward positive infinity right here. This is negative times s times positive infinity. We have to make sure that s right here, this right here has to be, let me just put it down. We have to have, so let me put down need, s to be greater than 0. That's a condition that we have to set. If s is greater than 0, let's check this again. Negative times positive s times positive, this will give us negative infinity altogether. E to the negative infinity, that will give us 0 times 1 over negative s, that will be 0. So we want this to be 0, and we can do so by restricting ourselves to have s is greater than 0. That's all, right? So let me just show you, you know we want it to be 0 if you have this condition at the end. So we'll put that down, but let me just say this is going to be 0. And then minus that, which becomes plus 1 over s. 0 times s is 0 times negative, which is still 0. E to the 0 is just 1, so we have 1 over s, right? And then you see negative, that's 1 over s. Anyways, all in all, it's just going to be 1 over s. And once again, we have to attach that condition that we put down earlier. 1 over s, as long as s is greater than 0, and this will be great. That's it.